Okay, Assalamualaikum and good morning. LUX function and graphs. 8.1 the relation and function. Find the domain and find the range of the function. Okay, first here definition of the range. The range of the function, the value of y, where the graph here defined or exists, and you can refer to the y-axis. To determine the range or the possible value of y of the quadratic function, you look for the lowermost and the uppermost y values on the graphs. Yeah. Examples of the quadratic function. Okay, here example of the quadratic function. If x here equals to the x squared plus 2. Okay, from the graphs of the quadratic function, you find the range of the function. So the lowest value here, y equals 2, and the range start at the 2 to the positive infinity. So the range of the function, bottom ups. Okay, bottom ups 2 to the positive infinity, and you state the range of the function here, start at 2, using the semi-open bracket 2 to the positive infinity. Yeah. And second, you find the domain of the function. Domain of function, the values of x, where the graph here define or exists, and you can refer to the x value. Yeah. Examples of the domain. Okay. So to determine the domain of the quadratic function, you can check all the possibles, the x value of the quadratic function. You look for the leftmost and the rightmost, the x value on the quadratic function. So here, you can check the value of x from the left of the function. Start from here. Okay. So the x value of the quadratic function start from the negative infinity to the positive infinity. Okay. Here equals to the negative infinity and to the positive infinity. Okay. So you state the domain of the quadratic function here from the left of the function, negative to the positive infinity. So domain of the quadratic function defined for all the real numbers. Okay, here is two methods to find the domain and the range of the function. First method here using the graphical method, and second method algebraic approach. Graphical method, first you find the y-intercepts, x-intercept of the function, and then you plot all the point and you sketch the graph of the function, and then you find the domain, find the range of the function. Okay. Okay, here are examples of the graphical method. State the domain and range of the following function using the interval notation. Okay, first function, you find the range of the function. So the intervals here between 2 and -4, bottom ups. So the range of the function start at the lowest value y here equals to the -2 to the y here equals to the 4. So you state the range of the function -2 to 4, yeah, bottom ups, and you find the range of the function here. Okay, and you find the domain of the function from the left to the right of the fx. So from the left here, the value of x equals to the -3, and here the value of x here equals to the 3. So this function only defined between -3 and 3, and you write down the domain of the function -3 to the positive 3. Okay, constant function, general form fx equals to the k, and the domain of the constant function defined for all the values of x, and domain of the constant function here, all the real numbers, negative to the positive infinity. And the range of the function for any value of x, the value of y here equals to k, and the range of the function here equals to k, or range of the function here equals to the 7. This one you labels the graph here, fx here equals to the 7. Okay. Okay, example. Sketch the constant function when fx here equals to the 4. First here, you check the value of k here. So value of k here equals to the 4. Okay. And you sketch the horizontal line between negative to the positive infinity. Constant function, very simple. You just sketch the horizontal line. Yeah. Horizontal line at the y here equals to the 4. Yeah. And here you labels the function fx here equals to the 4. Okay, very simple. Yeah. And from the graph of the constant function, you find the domain. Domain here defined for all the real numbers, negative to the positive infinity. You check your answer. Yeah. And the range of the function, range of the constant function here equals to the k, and range here equals to the 4. Okay, second function, linear. Linear function with the general form fx equals to the ax plus b. A and b are constant. And domain of the linear function y here defined for all the values of x. And domain of the function is all the real numbers, negative to the positive infinity. And range of the linear function x here defined for all the values of y. And range of the function is all the real numbers. This one you punya correction. Okay. And then you sketch the graph of the linear function. Okay, here example. Sketch the graphs of the linear function fx here equals to the 2x minus hat, and find the domain, find the range of the function. Okay, before you sketch the graphs of the linear function, first you find the x-intercept of the function. Y here equal to the 0, so you find the value of x. So you find, you let the y here equal to 0 and equals to the 2x minus hat, and find the value of x. X here equals to 4, and the x-intercept at the 4, 0. Yeah. And step 2, you find the y-intercept of the function. X here equal to 0, and you find the value of y. You substitute 0 here into the function. 0 minus 8, and y here equals to the negative 8. And then y-intercept here at 0, negative 8. Yeah. You plot the x-intercepts, y-intercept of the function at the 4, 0 and 0, negative 8. First intercept here at the 4, 0. Okay. Second is intercept, you plot at the 0, negative 8. And then you sketch the straight line to the positive infinity. Here is the answer. Here you plot the intercepts, and then you sketch the straight line. Yeah. Okay. Yeah. Okay. Here you labels the y-axis of the function, and here x-axis of the function, and here you put the arrow. Okay. And from the graphs of the linear function, graphs here defined for all the real numbers, domain negative infinity to the positive infinity from the left to the right of the function, and the range of the function bottom ups defined for all the real numbers negative to the positive infinity. Yeah. Okay, number 3, quadratic function. General form of the quadratic function fx equals to the x squared plus bx plus c. And here you find the domain of the quadratic function. Domain of the quadratic function defined for all the real numbers. Domain here, all the values of x from the left to the right of the function. Yeah. Okay, you list down the domain. Domain here negative to the positive infinity, all the values of x. And the range of the function, you start at the bottom ups. Bottom ups start at the negative infinity to y here equals 2. Okay, so answer you here between negative infinity and 2 using a semi-open bracket. Yeah. Okay, second, graph here open ups, and then the minimum value at the -2, -5, and y-intercept here at the -1. So you check the domain of the function. Domain here defined for all the real numbers, negative to the positive infinity. Yeah. And the range of the function bottom ups, and the minimum value of the quadratic function here start at the -5 to the positive infinity. Yeah. So you state the range here -5 to the positive infinity using the semi-open bracket. Okay, question, sketch the graph of the quadratic function fx here equals to the x squared minus 4. And before you sketch the graphs here, you find the x-intercepts and the y-intercepts of the function. Okay, x-intercept of function, y here equal to 0, so you find the x-intercept. Y here equal to 0 equals to the x squared minus 4, and x here equals to the plus minus 2, and x-intercept at the plus minus 2. Yeah. And the y-intercept of function, x here equal to 0, so you find the value of y. You substitute 0 here into the quadratic function, 0 minus 4, and the intercept here at the 0, -4. Yeah. Okay, you plot all the intercepts. First intercept here at the -2, 0, and here positive 2. Yeah. And then the y-intercept of the function here at the 0, -4 here. And the graph of the quadratic function here open ups. Okay, so you sketch the graphs. Okay, here is answer. You labels the axis, y-axis here, and x-axis of the function. Yeah. And the domain of the function, all the values of x, all the real numbers, and the range of the function here, -4 to the positive infinity. Okay. Okay, cubic function, fx here equals to the ax cubed plus bx squared plus cx plus d. And domain of the cubic function defined for all the values of x, negative to the positive infinity. And the range of the cubic function is all the real numbers. Okay, rational function. Before you sketch the graph of the rational function, here is the step. Step 1, you find the horizontal asymptote of the function. Okay, HA. And step 2 here, you find the vertical asymptote of the rational function, BA. And step 3, you find the intercept, x-intercept of the function, y-intercept of the function. And last, you sketch the graph of the rational function. Okay, step 1 to step 4. Okay, here is the example of the rational function. You find the domain, find the range of the function. Vertical asymptote here, x here equals to the 3, you labels. And y here equals to the 4, horizontal asymptote. Yeah. Okay, domain of the rational function, y here defined for all the values of x, except x here equals to 3. Okay, so domain of the rational function here defined for all the values of x except the vertical asymptote. Yeah, so you write down the domain here in a solution set or answer you here in a interval notation. So from the left of the function, domain here negative infinity to x equals 3. So here you labels. Okay, so first interval of the rational function from the left, negative infinity to x equals 3, unions 3 to the positive infinity. Okay, so domain here, all the values of x except the vertical asymptote at the x equals to 3. Yeah, and the range of the function, x here defined for all the value of y except y here equals to 4. Okay, and the range of the rational function here defined for all the values of y except the horizontal asymptote of the rational function. Okay, range of the rational function bottom ups, negative infinity to y equals to 4, and unions 4 to the positive infinity. Yeah. Okay, question 2 and question 3. Okay, here examples of the rational function with the quadratic denominator. You state the domain and state the range of the rational function. Here you labels the vertical asymptote of the function x here equal to the 0. and x here equals to the 4, and the y here, horizontal asymptote y here equals to the 1. Okay. Okay, so you find the domain of the rational function from the left of the rational function, start from the negative infinity to x equal to 0. First interval, unions 0 to the positive infinity, unions 4 to the positive infinity. So answer you here, domain of the rational function, all the values of x except the vertical asymptote, 0 and x equals to 4. And second, you find the range of the function from the negative infinity, start from here. Okay, range of the function bottom up from the negative infinity to the positive infinity. So the range of the rational function here defined for all the value of y. Yeah. Okay. Question 4. Sketch the graph of the rational function and state the domain and state the range of the function fx equals to the 4 over 16 minus x squared. Okay, check your answer. First first step, you find the vertical asymptote of the rational function. Okay, first, before you find the infinite limits of the rational function, first you let the denominator 16 minus x squared here equal to the 0, yeah? And factorize the quadratic equalities. 4 minus x times 4 plus x equal to 0. And you find the value of x. X here equals to the plus minus 4. And the method here using the infinite limits. So you find the infinite limits from the left and from the right of the 4 and negative 4. Yeah. From the left of the function, from the left of the negative 4, here equals to the negative infinity, and from the right here equals to the positive infinity. You check the value here from the left. The nearest value may be negative 4.1 or negative 4.001. Yeah, and from the right of the function, negative 3.9 or negative 3.999. Yeah, and x equals to 4. From the left here equals to the positive infinity, and from the right of the function here equals to the negative infinity. Yeah, and conclusion, you vertical asymptote here exists at the 4 and negative 4. Okay, step 2, you find the horizontal asymptote of the rational function. Okay, you find the horizontal asymptote of the rational function using the limits at the infinity. Yeah. You find the limits at infinity, limits of the 4 over 16 minus x squared when x here approaches positive infinity. And you check the highest power of the denominator here equals to the x squared. Okay, yeah, the highest power. And numerator here divided by the highest power and the denominator divided by x squared. Yeah. So 4 over x squared and here 16 over x squared and x squared over x squared. This one you cancel and here equals to 1. And here correction, denominator here 0 minus 1. Yeah. And when you substitute the infinity into the function, 4 over infinity answer you here equal to 0. And 16 over infinity answer you here equal to 0. And answer equal to the 0 here. Yeah. And here you find the limits of the 4 over 16 minus x squared when x here approaches a negative infinity and the highest power equals to the x squared. Okay. And then you check answer, substitute the value negative infinity into the function. Answer you here numerator 0 and denominator 0 minus 1 and here equal to the 0. Okay. Y equal to 0 is a horizontal asymptote of the rational function. Okay. Step 2, find the horizontal asymptote. And step 3, you find the intercepts of the function. Okay, step 3, you find the intercepts of the rational function. X-intercepts when y here equal to 0, so you find the value of x. So you let 0 here equals to the 4 over 16 minus x squared. And answer you here, x-intercept does not exist or undefined. So here answer you is 4 over 0 or equal to the infinity. Yeah. And y-intercept of function x here equal to 0, so you find the value of y. So you substitute 0 here into the rational function. F0 here equals to the 4 over 16 minus 0. And answer here equals to the 1 over 4. And here y-intercept here exists at the 0, 1 over 4. Yeah. And step 4, you sketch the graph of the rational function. So here you labels the vertical asymptote. Here x here equals to the negative 4. Okay, x-intercept equals to vertical asymptote equals to the plus minus 4. Okay, and the horizontal asymptote here at the y equal to the 0. Yeah, and the y-intercept function at the 0, 1 over 4. So here you labels the intercepts and the x-intercept of the function D and E does not exist. Okay, and from the graph of the rational function, you list down all the values of x. Yeah, intervals here from the left, negative infinity, -4, and then between -4 and 4, and then the third interval here 4 to the positive infinity. So domain of the rational function, negative infinity, -4, unions 4, -4, 4, unions 4 to the positive infinity. Yeah. Okay, and the range of the function, bottom ups. Okay, the range of the function bottom ups start from the negative infinity to the y equal to the 0. Yeah, start from your first interval here, and then unions 1 over 4 to the positive infinity. Yeah, between y equal to 0 and y equals to the 1 over 4. Here, the graph of the rational function d and e does not exist. Yeah. So between 0 and 1 over 4, uh, rational function here undefined.